We are continuing our lesson on law of signs, and today we're going to look at the ambiguous case, which is SSA, meaning you have a side, and an angle. And in this situation, the ambiguous case situation, there might be no triangle, one triangle, or two different triangles. We're not sure. We have to test for it. So what I mean by that is I'm going to try to give you a visual of what's happening in the ambiguous case. Say I have a straight line going across, and I'm not going to tell you what that length is. It can be any length. We don't know. And I'm going to say that we're given a 30-degree angle. I'm going to say angle A is 30 degrees. And I'm going to say that one side for certain is this board. So I'm going to say that this right here is the length of the board, and I just measured this board. It's 12 inches. So this is 30 degrees. That's given. This 12 inches is given. And I'm going to say the other side is this marker. And this marker, if I measure it, it is 4.5 inches. So I'm going to say that this marker is the other side of the triangle, and it is 4 inches. Okay, so this is an example of a triangle that does not exist, okay? And let me explain why. If I were to draw, let me label this as angle B and angle C. So that means this is side A. So I'm saying side A is 4 and side B is 12 inches. Okay, so these three items are given. We cannot change it, okay? I can't extend this 4 inches to make it stretch. It stays 4 inches. However, they did not tell me about this line. So I don't know how long this side is. These are the only two sides that were given. Okay, so I'm going to just draw the height of this triangle. I'm going to turn this into a right triangle in here. If I do that, I can find the length of this height by doing SOHCAHTOA. I'm going to do sine of 30 degrees. Opposite is the height, and the hypotenuse is 12. So if I multiply both sides by 12, I can type this into the calculator and figure out what the height of that triangle is. The height of this triangle is 6. Okay, so that means if you were to swing this 4 inches and swing it this way, it would not be long enough to close the triangle. It's too short. So this leg is too short. So that means no triangle exists. There's no triangle in this situation. This leg is way too short to even reach this other side. And guys, we cannot adjust this 30 degrees. It's stuck, okay? No matter how much you swing this 4 inches, it will never close that triangle, okay? How about we do this calculator? So let me measure this calculator. 7.5 inches. So let's change this side to 7.5 inches. Okay, now is that long? Oh, 7.5. Now is that long enough to close this triangle? Yes, why? Because what? Yep, it's more, well, it's more than 6, exactly. It has to be longer than this height. Now, I want you to visualize something. This calculator is 7.5 inches. And the reason why I'm doing actual objects is so that you can see that I can't change the height. I can't change the length of this calculator. That is given. So say this is 7.5 inches. This is the case where you're gonna have two triangles. This right here is 7.5 inches. And if you were to swing this calculator this way, it can form another triangle right here. And this is also 7.5 inches. That's two possible triangles. The reason why I can swing this calculator this way is because they did not give me this angle. Okay? They only gave me this angle. So there's many possibilities in this triangle. This triangle is not set in stone. Okay? So in this case, if this length right here is between the height and this length, then you can create two triangles. So that is a case where you would have two triangles. So no triangle, that means that this given length right here side A was less than the height. That's no triangle. If A is between the height and the other side, side B, that means you're gonna have two triangles. Whenever you create two triangles, I'm just gonna draw this one. You have this triangle. A, I'll call this C, and this is B prime. I'll call this one triangle, and then the other triangle was the original one, where this was A, C, and B, okay? And this is 7.5, this is 12 inches. And if you swing this 7.5 this way, this side is still 7.5 inches, and this is still 12 inches, okay? Now let's just pretend here. Let's say I use law of sines and I figure out that this angle right here is 60 degrees. Guys, this is an isosceles triangle right here. So if this angle is 60 degrees, that means this angle right here is 60 degrees. If this is 7.5 inches, this is 7.5 inches. This is an isosceles triangle right here. So since this is 60 inches, I know that this inside triangle in here is 120 inches. So I know that this side is 120 because on straight lines you have to add to 180. Okay? So that means this is 60 inches and this is 120 inches. These two, the two different angle B's, have to add to 180. All right, moving on. The other instance that you can have, this was 12 inches, this was 30 degrees, is if this side is way longer. Let's say that it is 20 inches. Okay? That means this will definitely close. I don't know how long this other side is, but it will definitely close. And if you swung it this way, it's way too long to form a second triangle. Okay? So whenever this side is bigger, it's bigger than your other side, that means you're only gonna have one triangle. And this is the chart that you have at the bottom of your notes, so you can look at that to refer to it. Sorry. Okay, so if you don't want to memorize this table, that's fine. I'm going to show you how to do it algebraically.